Inside every single gadget you own, there's this hidden hero, this complex foundation that makes it all tick. Today, we're going to pull back the curtain and explore the world of the printed circuit board, or what you'll often hear called a PCB. So, let's start with a little pop quiz. What do your phone, the dashboard in your car, maybe even your smart coffee maker all have in common? I mean, really think about it. What's the one thing that connects them all on the inside? You got it. It's an electronic blueprint. Every single one of them has a printed circuit board. You can think of it as the central nervous system for your tech. It's this amazing hidden architecture that gets all the different parts talking to each other, making sure they work together in perfect harmony. So, how do we get from a simple idea to one of these intricate little boards? Well, here's our game plan. We'll start with the blueprint itself. Then we'll look at how the board is actually built. From there, we'll dive into designing for the real world, trace the journey from an idea all the way to a finished product, and wrap it all up with why this whole thing is so incredibly important. All right, let's dive right in. Section 1, the electronic blueprint. So what is a PCB really? And why is the design stage just so absolutely critical to get right? So PCB layout and design, it's basically the art of creating the physical map for an electronic circuit. And I love this analogy. Think of a designer as a city planner for a super complex, microscopic city, right? They have to decide where every single building, those are the electronic components, is going to go. And then they lay down all the roads, the tiny copper pathways that connect everything, making sure all that electrical traffic flows exactly where it needs to with no jams. Okay, so you've got the blueprint for your city, but now you have to ask yourself, what kind of city are we actually building here? Because, believe me, not all circuit boards are created equal. I mean, the options are all over the place. You've got everything from super simple, single-layer boards for, a basic kid's toy, all the way up to these incredibly complex, multi-layer designs that power our smartphones and computers. And the choice you make? Well, it changes everything for the final product. And this is where it gets really cool. On one side, you have your standard rigid boards. These are the solid, dependable workhorses you'd find inside your desktop PC or your TV. But then you have flexible boards. These things can literally be bent and folded. This is the magic that makes tiny wearable gadgets like smartwatches and even medical implants possible. It's a total game changer, letting engineers cram electronics into all sorts of crazy shapes we never could before. Okay, so you've got your blueprint, you've picked your materials, but here's the million-dollar question. Will it actually work when you go to build it? This brings us to a super important step, designing for the real world. First up is a big one, DFM, which stands for Design for Manufacturing. You can think of this as the ultimate reality check. It's all about making sure that your beautiful computer design can actually be built in a factory, efficiently and without a bunch of defects. It's about avoiding that nightmare scenario where you realize halfway through production that your design is physically impossible to make. Then we've got DFT, or Design for Testability. Look, it's great that you can build the board, but how do you know it actually works, perfectly? That's where DFT comes in. It's this clever process of building test points right into the design from the very start. This makes quality control way faster and easier. Without it, trying to find one tiny little flaw would be an absolute needle in a haystack situation. And last but not least, there's EMC, electromagnetic compatibility. Let's face it, we live in a soup of electronic signals. Wi-Fi, Bluetooth, cell signals, it's everywhere. EMC is all about making sure your device plays nice with others. It ensures your gadget isn't shouting over other devices, and just as important, that it doesn't get messed up by their signals. The soundproofing analogy is perfect. You want to keep your noise in and their noise out. All right, let's pull the camera back a bit and look at the whole shebang. How does all this detailed design work fit into the grand journey, from a sketch on a napkin to a product you can actually hold in your hand? See, PCB design, as critical as it is really just one piece of this giant puzzle. The whole journey kicks off with prototyping, then moves into the electronic design and software coding. After that, it's off to manufacturing and some seriously tough testing. And finally, you have to figure out the logistics of actually getting the product to people. It's this whole interconnected pipeline where one little hiccup in one step can mess up everything down the line. Let's make this real with an example. So to get the ball rolling, a client might just show up with a schematic. And yeah, it could even be a sketch on a piece of paper. They'll also provide a list of all the parts needed, which is called a bill of materials. From just that, the design team gets to work and creates something called Gerber files. These files are the universal language for PCB manufacturing. They're the final blueprint. And they can turn this around in just a matter of days.
And the speed of modern manufacturing is just mind-blowing. We're talking about companies that can turn out 100 of these large production panels for boards with up to 10 layers in just 5 to 7 working days. That speed from a digital design to a physical product ready to ship is absolutely incredible.
Okay, let's tie this all together. We've talked about the design, the different types of boards, the whole process, but at the end of the day, why does all this careful, integrated planning really matter? This quote here really nails it. A fantastic product isn't just about a clever circuit design on its own, it's about teamwork. That little circuit board has to fit perfectly inside the product's casing, right? And that means the electrical engineers and the mechanical engineers have to be in constant communication, working together, hand in hand. So here's the main takeaway. In the tech world today, things move so fast. You just can't design something, throw it over the wall to a factory, and cross your fingers. The only way to win is with an integrated, end-to-end approach, where design, manufacturing, testing, all of it is seamlessly connected. That's how you get amazing electronics to market, and you get them there fast. And that leaves us with a final question to chew on. Our devices are constantly getting smaller, smarter, and more connected. So what does that mean for these electronic blueprints? How are they going to have to evolve? The tiny cities inside our tech are only going to get more crowded and more complicated, which means designers will have to come up with solutions we can't even dream of today.